Hi everyone. Today let us understand how to read electrical drawings. This is one of the very important subject for any aspiring electrical design engineer. And uh, because of the size of the drawing, I could not accommodate them inside this presentation. So let me go to the screen share mode and show you what it is and how large these drawings are. So this is one of the practical example that we worked a long back. This drawing is called a layout drawing for the entire plant. Being an electrical design engineer, you need to understand about the particular plant on which you are working. So, what I mean to say is that this is a layout drawing for a cement plant, and you or we as an electrical design engineer need to understand that the process of that cement plant. So what are the raw materials required and what are the step-by-step process to finally getting the cement. Now let me just show you how to identify the different buildings and parts in this drawing. For example, so this drawing is showing different things. So this is something, this area is left for something else, this area is left for something else. So what are those some things we need to identify? For example, so let us take this example of 26 and 19. What are these things? So we'll go for the legend because we don't know what it is. So we'll find it. 19 is raw mill building and 26 is load center 4. So that's how we need to identify all the buildings which are required for the electrical engineers. Now, load center is something is one of the very important building where all the HT boards, LT boards, uh, the transformers are kept. So from where the distribution starts and where from where one load center to another load center and finally to the load, that's how the distribution power distribution part is. So we need to identify these buildings first, and then what we generally do is take a printout of a in the A0 or A1 and start marking those important buildings for electrical distribution, and then we mark the tray route. So for example, this 19 raw mill, but this 26 is the load center 4. So from this load center 4, there will be distribution of power through the power cables. So there will be a tray route required. So we can mark tray route like this. For example, the cables will come here and connect to this red line. Then red line is a tray route, and this will go like this. And for the downstream, it will go like this. That way, we need to identify all the load centers, all the load points, and the tray route in this drawing. And for that, we need to know the process and where the loads are situated, where the load centers are situated, where the loads are situated, and through which we can take the cable route. For example, this looks like there will be a structure, and that's why I have drawn this line that we can have a cable tray route here. So this will come with experience gradually, through which uh, we can draw a cable tray route. So that is the layout. So I just wanted to tell you the vastness of the work that one need to do. The work that I have just told to that we need to do to find out the total length of cable. It will take at least 15 to 20 days for an engineer, for one engineer to work full time on this item. And these are the things called grid. These are the things. These are grids. Grids are given to mark a particular building with grid numbers, and also to understand that what is the length and width of that particular plant. For example, this distance between two grid is 750 and 800, means 50 meter. So if there is 100 grid, then it will be 5 kilometer. Similarly, I think there will be 100 grid on top also, so it will be another 5 kilometer on the top. It's a 5 kilometer by 5 kilometer plant, so it's a huge plant. Now let me take you to this electrical part of this drawing, that is also huge. So we need to understand the distribution part of this plant, electrical power distribution. For that, we will identify from where it started. So give you an understanding how big it is. So this is the total distribution. It's not even coming in one page. So this is the total distribution. Uh, so we need to identify this. So this is the grid, and this is the grid, and from here 132 by 11 kV transformer, which is feeding this MPSS. Somewhere it is called MRSS switchboard also. This is an 11 kV switchboard, and in this there is one incomer and two outgoing. We, as an electrical design engineer, we need to know these symbols. I have already prepared one video for these symbols and their meanings. For example, this is transformer. This is delta side symbol. This is star side symbol. This is city symbol for city, and these rounds. This is called R, means relay, and these rounds are also meaning to the IDMT relay. The numbers means the ANSI code. Every code has a different function. This is isolator and NGR combination together. These are city. Then this is an VCB breaker symbol. These arrow symbols suggest it is a drought type breaker. These are PT symbols, fuse and PT combination of this. This is called line PT because it is connected to the line, and this is called bus PT because this is connected to the bus. This is the bus bar, and the rating of the bus bar is 11 kV unearthed. EV means unearthed, 4000 ampere, 4000 ampere, 44 kilo ampere for 1 second, 3 phase, 50 hertz bus. Now let us understand the distribution part of it. This feeder is called tie feeder, and this is a spare feeder written over here. There is nothing after this. It is coming up to this transformer only. Now this tie feeder is feeding this switchboard MBSB 101. This MBSB 101 is the very large HT board, and after that there is further distribution. This breaker, outgoing breaker, is connected to this breaker as an incomer. So, and after that there is further distribution. It is coming to different load. You can see it is coming to different load, and also coming to transformers, and from transformer it is going to the further distribution. If anyone knows what is this, this is an harmonic filter. You can comment me the reason why it is used, and I will also prepare a separate video on what is harmonic filter and why an harmonic filter is used. This is a symbol of an MV and this motor is connected with an LRS, liquid rotor. That's how the distribution is. So first, this 33 kV, then it is divided into distributed into 11 kV. From the 11 kV there are multiple 11 kV boards. There are multiple 11 kV boards, And from the 11 kb board, some feeders which are already in 11 kb has been directly fed, and some feeders which are not in 11 kb fed through a transformer and then bus duct, and after that there will be further distribution. For example, this transformer, this is 11 kb by 433 transformer, means LT distribution will start from here. And after that, there is no further drawing provided by the consultant or the client. It is the list of loads that is supplied to the EPC vendors to do the further design. One more thing, so is that even if you don't understand any symbol, you can find it here. So generally, legend is on the right side corner of the drawing, and you can see all the symbols and their meanings are given. These are VCBs, circuit breakers. These are potential transformer. This is motor with LRS, ammeter, voltmeter, kilowatt hour meter, current transformer, voltage transformer, frequency transformer, multifunction meter, ammeter, selector switch, and these are IDMT relay, their numbers, ANSI codes, ELR, leakage relay, and this is MB VFD. So that's how you can find out the symbols and their meaning. One more important thing that I have seen many people miss, particularly those who have recently joined as a design engineer, is to read the notes. This is extremely important. Let us read it. Only distribution scheme is shown. Refer tender specification for relay protection and metering. Energy meters are not shown in drawing. These meters shall be provided in each incomer and outgoing. Just look at it. If you don't read and if you miss it, you are not considering any of the energy meters. So as a result, maybe you will get this job because your price will be low, but during the execution it will be surface out that energy meters has to be supplied and it has not been considered, so it is a hole to your profit. So you have to pay, I mean, this company for which you are working have to pay from their own pockets. That is why this is extremely important to read these notes. I think that is enough for today's video, and I'll prepare another video how to find out the LT loads and how to design with the LT loads, the LT side distributions. So thank you.